Thank you for that introduction, Dharmender. I'm really excited to be able to share a little bit more about the work that I've been doing on the teaching front today. And so I'm just going to confirm that everyone can see my screen just fine. Yes?
Yes, and just an announcement. So I would request that all the participants please mute yourself, and I will be moderating the chat. So whatever questions you have, please post your questions there. And towards the end of the webinar, I will ask Dr. Raturi all the questions one by one. Thank you.
Sounds good. Thank you. So I have quite a bit of material prepared, mostly to give you all a little bit of an insight into how the agricultural informatics course that I designed is actually built. And so I want you to really think about this as an invitation to thinking about whether or not we should start an agricultural informatics learning community, right? Part of the joy of building open courseware is to be able to then actually share it with other people and also have people use it. And so I'll show you a little bit about what's going on. Mostly I'll start with a quick background and who I am and why I care about ag informatics. I'll introduce you to the intro course in ag informatics. We'll go through the guts of the course itself, and then I have a little bit of space for us to be able to just chat more about, right, the value of a learning community, if, when, how, and those kinds of things. So just a quick bit of background. So as Dr. Saraswat mentioned, I'm an assistant professor here at Purdue University. And I actually share this slide usually to describe where my background is, right? So my grad school work was primarily in software engineering. Before that, I was in computer science, but I also lived outside of the US. And so I have a slightly different experience, perhaps, of maybe what people think about when they think about the digital divide. So when I think about both computing, technology, agriculture, food systems, sometimes the images that come to my mind are a little bit different. But what that has allowed me to do is both think deeply about, what are the types of tools that different kinds of folks need? How are different folks accessing information? What are the different kinds of learning challenges faced by people both within and outside of the United States educational context, and so on and so forth. And so a lot of these rich images have really driven particularly my research, but also the way in which I think about teaching in the context of food and agriculture. So I'll start with just a quick, scene setting, right? I think a lot of us in the room who are interested in education on this topic already think about, right, agriculture, food systems, and the work that we do within them as knowledge work. And in that sense, we're really thinking about how do we train that next generation of knowledge workers, right? Because a lot of people, regardless of whether or not you're a full-time software engineer, right, everybody is really using data to learn something, to solve a problem, to make a decision. And so it means that what I really wanted us to be thinking about in this course was to be able to support different kinds of decision makers, different kinds of technology builders, as well as technology users, right? Not everybody has to become a software engineer when they grow up, but ideally everybody gets a little bit more digitally literate. So that way, when we're starting to perform, right, these different kinds of knowledge work throughout the food system, we're able to think critically about what data should I be collecting, how should I be putting it together, what technology could I be using, and what are the opportunities for design as I imagine the future of digital agriculture. And so we know that, right, food and farming systems are complex adaptive systems. There's a variety of different kinds of data that are coming together. And we know that we want our students to be able to actually bring these different disparate data sets together, to be able to integrate them, to be able to analyze them, to be able to ask critical questions about them, and really think about, right, data in agriculture, data in food systems a lot more holistically. And so that's kind of the scene that we're setting when we're thinking at least about the data front. The other half of this is that there's a lot of questions around adoption in digital agriculture, right? We build lots of tools. We spend a lot of time thinking about different kinds of technologies. And the question remains, right, what do people want, right? What is appropriate technology in the context of food systems? And that answer is different in very many different places. And so another part of this course really starts to ask questions around usability, usefulness, and really being able to translate user requirements to technical specifications. And so what we're really trying to do with our students is really help them kind of see this journey of continuous improvement and the fundamental building blocks of the technology that can actually allow people to graduate, right, from being able to ask questions about what happened on my farm, why does it happen, what do I want to change, and how can I actually improve the food system as a whole. And you can see at least a couple of the different technological building blocks that allow different kinds of food system stakeholders, right, answer a variety of these questions. And I think to many of us on the people that are doing research and education in this context already, some of these things might be obvious, but these are actually slides that I even use in my first lecture to be able to talk to students about, right, the value of technology and data and being able to help us push the needle on, right, different kinds of system change in food and agriculture. And so it means that, what I'm really trying to help students also see is the sort of stack of the ways in which we can go from data to wisdom, right? So if data are just observations about the world around us and information of that processed data, we want them to be able to think about tools to be able to help us manage knowledge, perhaps even build wisdom. And so when my students are coming into the class, they're really starting to think then about, okay, what do different kinds of data collection tools look like in agriculture? How do management information systems change, right? Farm record keeping systems are a perfect example of a domain-specific management information system. And so there are lots of different ways in which they can start to then also hang the software that they know on this sort of stack of genres of technology, thinking critically about where and when should I be building the decision support tool? What is the value of expert systems? What is the potential for artificial intelligence in being able to help people sort of move through this data stack? The other thing that we try to talk a lot about is, opportunities for design. There's a lot of technology already out there. We know a little bit about some of the different tools that students have exposure to. Usually it's not much. So, in this particular case, the farm tech landscape that I'm showing you is, yes, a very North American centric landscape, but it at least starts to show us a little bit of that diversity of technologies that students will be encountering when they go into the workforce, depending on what area they're working in, right? So there's actually quite a few really interesting farm tech landscapes like this that focus on different verticals, even some horizontals when it comes to thinking about technology and food systems in general. Right. But what I really try to have my students start to ask questions around is, what are the opportunities for design? Where do I fit in here? What are the tools that I might want to play with? And how do those fit into not just my toolbox, but the toolboxes of the stakeholders that I'm working with? And so here at Purdue, I also run a research lab that happens to be on this exact same topic. And so it really gave me a chance when I first started here in 2019 to ask questions of my own students with respect to, whether or not they had support for building the kinds of skills that we needed, whether it was in human-centered design, data and modeling, or software engineering, to then be able to go out into the world, work with different communities of practice, and actually build technology, right? And so the couple of different things that at least I was seeing students lacking the core skills in are reflected in this next set of slides. And so I'll just kind of show you a little bit of what my lessons were initially from just working with students in the College of Agriculture here at Purdue, and then broader reflections on kind of what some of the things that they need are. So the first thing that we found was, I would often talk about open source. I would talk about software engineering, but trying to think about, right, the engineering discipline as something that was maybe a little bit more accessible to students in the context of agriculture was really important, and trying to help them really see both the power of that iterative development cycle, right, where you actually start by understanding what users want, designing little prototypes, developing different kinds of architectures, and then actually refining and testing with users, right? That process in theory was obvious to many, but in practice was difficult for people to know, okay, so now how do I do this with software, right? Many students might have experience doing this with hardware or in other areas, right? So that cycle might be familiar, but understanding how this actually gets instantiated in the context of software and how to use open source tools to then actually help you go through that engineering lifecycle was something that we found students were interested in and perhaps also lacking to begin with. The other part of this, right, going back to this idea of, we want to be able to support our students in being able to understand user requirements and then translate those into technical specifications means they need to be able to understand ways in which you can draw on different methods to be able to, right, elicit user requirements. And so in the discipline of human-computer interaction, there are many different methods that we use, right? Interviewing and observations, building prototypes, doing usability testing, even data modeling as a method for understanding how humans and computers interact, right? that actually then allows us to go and do these targeted things when it comes to building technology, whether it's actually assessing the quality of user interface or being able to trace the information flows and the interoperability challenges among systems and so on and so forth. And so the next bucket of skills that I wanted students to get some experience with was, right, HCI skills broadly, so that they could then engage more concretely in things like user-centered co-design. So this is an example of some of the co-design work that we were doing in my research with external stakeholders. And so this is one of those skills where I wanted students to be able to know how to take, right, those lessons that they were hearing from stakeholders and translating those into actual mock-ups, prototypes that they could then go out into the world and build. So in my world, a lot of what I'm really interested in was being able to support the development of decision support tools like this. This is our cover crop species selection tool that we had supported the USDA in developing in its early days, right? And so many of us on the research side might want our students to be able to do some rapid prototyping and build web apps that are directly serving the needs that we've heard our stakeholders talk about. And so it means that students are sort of thinking about these socio-technical design challenges, right? It's not just about can you code, but it's also about, are you able to think about practicality for different user groups? Are you able to think about usability? Do you understand what interoperability means with respect to data formats and being able to move data across systems? And really start to think about technology, not just as this thing that you throw at people to use, but really technology is something that people either trust or don't trust with their data and their livelihoods. And so in a lot of ways, you know, the joke that I always make in class is that if you're in the business of building technology in agriculture, you need to stand the test of time and beat the spreadsheet. And so, you know, if we're going to start to actually think about like where we can learn best practices, it also includes from the tools that people have been using previously. But this is at least how I've been framing this course. Okay, so the course itself. Right, I define agricultural informatics as a practice of designing, building, and using digital technologies to enable people to do a variety of different domain-specific tasks. And so it means that what I want my students to be able to walk away with from this course is that core set of skills around being able to design, build, and use technology, and learn how to be able to then translate it to their specific domain of work. Right? Here in the College of Agriculture, we have many, many different departments from animal science, horticulture, agricultural engineering, and many others. And so it means that I needed students to be able to say, yes, this is how data is used in ag economics, or here's the potential of technology in agricultural education, and so on and so forth. On the other side of that, informatics is in and of itself also a network of disciplines, right? As I was showing you many of those different skills, each of those requires to pull methods from many, many different disciplines, from social science, where we learn how to interview folks and put together focus groups to be able to understand their needs, all the way through to data science, where we actually then sit down and think about how can I build a model to actually interrogate that data? How can I actually build different kinds of tools and leverage modern technologies to be able to support decision makers and so on and so forth. And so it means that the educational challenge is really, at least for me, I think of it as a balance between trying to understand how to help people foster technical skills while growing their domain expertise. And their domain expertise, they're growing in many other courses, but they're really coming to me in this course and hopefully to you as well for those core technical skills and that translation to their domain. Okay. So now that we've kind of gone over the sort of why this matters, how it's constructed, and the rationale behind this course, I'm going to dive into the course itself and walk you through the specifics. So we'll look at a little bit about how you can access the course. And so I'll encourage you to just kind of take some notes on the different links that I've shared in here. And I'm happy to make the slides available after the talk if you want to go poke around some more. Okay. So Intro to Ag Informatics now has a course number, so I'm very excited. We're ASM 532, which means we are a grad and undergrad course here at Purdue. But the core concept is that we wanted to be able to introduce students to current and emerging technologies, demonstrate those applications in ag, environment, and food systems, and then really help them think about how to build that on-ramp, right? It's a gentle introduction to computing concepts, and it's supposed to serve students across a range of agricultural disciplines, right? And so that's that challenge all over again, but this is kind of what we're trying to pack in our case, into about 16 weeks, which is a little bit of a doozy, but we try to make it work. We have 5 core learning objectives. I'm not going to read these verbatim, but I'll just kind of go over some of the highlights. And I think of these as objectives that do stack and then do map to some of those content matters. So the first one is really being able to help them get those core skills in technology design, in data analysis, and then even programming for the web. The second is to be able to support them in being able to actually formulate data science problems. Oftentimes, I want students to be able to actually look at their domain, look at the research, look at the other courses they're taken, and actually be able to identify, this is a problem where data might actually help me answer something interesting and make that next decision, right? And so being able to actually frame things as a data science problem, I believe is a core skill that they need to be able to walk away with. I want them to be able to critique and experiment with informatics. So not just saying, I'm just going to use this tool reactively, but really being able to say, is this the right tool for the job? If not, what tool should I go find or what should I build? And that leads us to the last 2, where I want them to be able to actually walk away being able to design and develop a web application and engage in that rapid prototyping, and finally be able to conceptualize novel informatics solutions to concrete problems in agriculture, environment, and food systems. Okay, so the course is structured in a modular fashion, and I'm going to go through each of these modules in much more detail later. So I'm just going to throw this at you really quick so you can get a bird's eye view of what the course is structured like. This means that you can basically pick and choose modules here and there to integrate into your own courses. So if you're thinking to yourself, I'm not sure if I want to actually teach this entire course, I might just want to integrate some of these materials into my own. Some of these work together better than others, and I'm happy to kind of walk you through how that works during the Q&A later. But these are the ones that I've designed so far, and so this is currently what we have available right in that library of modules. The only thing I'll note on the instruction team front is the importance, the critical importance of having a really good teaching assistant for the course. Every year, I've been grateful to have teaching assistant support. In this particular year that I'm taking the snapshot from, I actually had another student in training to basically become the TA for the next year. And so I've now started to try and actually integrate that mentorship model where I'll have a student that's actually coming in to serve as a TA for the next year that I'm working with right now already. And so it means that you kind of have somebody that's direct TA right now and the other person that's training and learning how the course works, because it is a very hands-on course. And so, you know, in the first year, even though I had a TA, there was still a lot of debugging to do, and it meant a lot of hands-on work with students, even just doing simple things like explaining how and where different bits of code are and how they work together. And so I would strongly encourage that if you're thinking about this course, think about your instruction team, not just you as an individual, especially if you scale your class size. And I'll note here also, my class size has typically been capped at 15. I think this year I'm now ready to start to increase that cap, but I probably would not recommend going over 25 with at least the way in which I've structured the content. But we basically have 2 lectures in a lab every week, and we go from there. Okay, so let's think a little bit about the audience for this course. Who is Intro to Ag Informatics for? Right? It is a 500 level course, and so it does mean that I have a lot of undergraduate students who come into the course as well, or at least I'm grateful when I do. We've been trying to open that up a little bit more. I think it's still a little bit scary for undergrads, but we're hoping that we can kind of explain how and why this fits into their curriculum. I typically encourage juniors and seniors who have taken some math or data course. They don't necessarily have had to program in the past, but really I want to know that they're, we're not going to start by saying, here's what a variable is. And so I have some supplementary materials for those students that come in with no experience at all. So that way we can help bridge them within that first 2-week period. And again, that's something we can talk about more if it's of interest. And I also try to encourage them to think about how this might fit into their study plan. So part of a data, tech, or other elective. And so I've been working with our advisors to try and better understand how that fit can work. Graduate students come in a little bit differently. I actually encourage them to come in their first or second year, right? They're just starting to get their feet wet and research. They're still trying to think about what they're doing. This is a great time for them to get some of those basic prototyping skills in their toolbox. Most of the graduate students I find have done some sort of coding course, even if it's an online coding course. And so I don't see them coming in with 0 programming skills, but tend to already have at least a little bit of that in their skill set. And that's because usually they're students that are coming in to do something technological as part of their graduate experience anyway. And so many of them will take this course and actually integrate it into their study plan so they understand how those technology skills that they develop can influence the rest of their learning as well as then their research. But the thing that's common with everybody is I find that the students that come to this course need to be highly motivated, and they often are. Because you need to really be able to keep up with the materials and be able to sort of overcome that hump of digital literacy. So we do have a high variance in the course. We have students from low to high digital literacy, and I encourage collaboration so that way we can actually think about ways in which, those with technical skills can support those with domain expertise and so on and so forth, and really come together trying to think about how can I learn, how can I plan my informatics learning pathway moving forward. Okay. The second way in which you can think about the audience of this course and the way in which you can tailor it are based on their comfort with technology. The first group that I get are often digital novices who really are looking for that first big course in computing. And I think it's been a good run so far because I have students that come in saying, I'm not really sure how this code runs, and being able to walk away saying, okay, I now know how to build a web app, yes, but I now know how to go and find the things that I need to do to be able to tinker with technology. And that's my biggest goal for them, right? Is I want them to feel comfortable to be able to just experiment. And so usually I try to make the on-ramp a little bit gentler for them, and I work with them a little bit more at the front end of the course, and they gain experience with the technologies, learning the vocabulary, and learning how tech works. The other group I have, and this is usually the minority of students in the course, but I do get students that are digital experts, so a computer science student or someone from electrical engineering who's actually coming for the domain expertise. And so what they're coming to this course for is an introduction to domain-specific issues and really looking to gain experience with a variety of domain problems. In their case, they're learning vocabulary about how we talk about technology in agriculture, and they're learning about real use cases. Again, just to bring the two groups together, right? They're highly motivated to gain those skills. And that means that the thing that they're hopefully walking away with is they're learning how to design software in practice. Right. So this is very different from a theoretical computer science course where you learn the algorithms. This really is focused around how do you apply your lessons and build things that are right in support of real users. So the student experience is extremely high touch. There's active learning in lectures. We have hands-on work in labs. I have a self-assessment via quiz, and then they engage in critical thinking via the project. So we end up having to provide resources to support student learning across the spectrum. I try to provide course visibility so they can plan way ahead and really try to think about adaptive learning as I hear what people are struggling with, what people want more of, what people seem to be doing just fine with. And so you see on this image over here, this is my Brightspace, my learning management system instance. And right off the bat, I point them to that GitHub repository, which is where they're getting all their information. And then I start them off with just a couple of Python resources. But you'll notice many of these things are links to GitHub because I want them to start to get comfortable with that technology right off the bat. And then you also see over here, I'll usually have the full set of assignments baked in so that way they can look ahead and think about how much work they're going to have to put in when, because time management ends up being a really big part of their success. So if you want to access the course materials, there is a link here. I believe Dr. Saraswat has sent one that does have a form that we would love for you guys to fill out before you actually access the course, or if you already have, please still fill out the form because it helps us at least understand who is interested in using the course and how. But here's how it works in details. I'll zoom out really quick and just talk a little bit about open source. For those of you in the room who might not already know, right, open source software is software with source code that anyone can inspect, modify, and enhance. And you can think of this course as the exact same thing, except the software that you're looking at, the source code that you're looking at is all of my learning materials. And so it means that, I really do try to live the open source way and try to share my materials. I'm very pro collaboration. But it does also mean that, right, I'm really committing to playing an active role in improving the materials and maintaining them over time. And so it means that if we come together at the end saying, yes, indeed, a learning community is where we want to end up, then, we'll have to think a little bit about also what those commitments might look like. And so if you look at the courseware itself, you'll notice there is a license on every single material. And that's basically a way for us to make sure that both you know what your rights are. So you're welcome to share it. You're welcome to adapt it, right? So you can remix it, you can tweak it for your own course. The only thing that I ask is that you provide attribution, do not use it for non-commercial purposes, and just make sure that you're at least a little bit comfortable with the Creative Commons license. But this is a common way in which, content is shared, even in Wikipedia, and is an increasingly common way in which people are developing and disseminating courseware, especially in computer science. And so I'd like to bring that tradition over to ag engineering as well. So if you want to actually look at the repository, if you click on the link, you'll see something like this. And so if you just want to follow along to start and just say, I'd like to find this again in the future, once you've created your account, you'll click on that button and you'll star the repository. If you're like, I'm ready to tinker, I want to actually try stuff out, I would suggest you fork the repository so that way you can actually keep a version of it on your own account that you can then tinker with and experiment with without breaking the main course. From there, if you want to actually just keep the live course on your local machine, then you'll clone the repository like this. I'm showing you how to clone it in your terminal. This is a demo I did on Tuesday in the first lesson of the class. And so students also then get the materials in this particular way. So once you've cloned the repository, it's now on your local machine and you should be able to navigate it and basically look at the course as it's released, right? So in the current version of the live repository, you'll notice only module 1 is available. But if you go to the releases in the corner, you can go see the previous editions and get the full course, right? So every semester, every year, basically in fall, I reset the repository and remove all the modules so I can release them one at a time. But every edition is there for your perusal. Okay. So if you want to browse the course modules online, you should be able to come in and basically just walk through this. You'll see my syllabus there, but you have a link in the course structure. And so this kind of helps you sort of read the breadcrumbs at the top and know where you want to go. So if you click on module there as well, you'll get to the same spot. And you can now basically look at one module's entire set of materials, right? So again, it's going to be 4 lectures, 1 lab, 1 quiz for every module. The only thing, so when you bring it down onto your local machine, you can actually just navigate to the place where you've stored it in your browser, and then you'll see it like this. And the only thing that I'll note is the quiz questions are not in the repository because I have them set up to auto-grade in Brightspace. And so I'm just going to work on downloading them if there's enough interest and then integrating them into this repository. But if you're really hankering for those quiz questions, let me know and I'll see what I can do. Okay. The high level, big picture of the course. I know we're at 30 minutes and I do want to leave some space for time, but I think it might be helpful to just kind of see if you have questions right now, please pop them in the chat so I know how much discussion time I should be leaving. Otherwise, if it's all right with you, Dr. Saraswat, I might just continue reviewing the core materials. Yes? I'm going to take that as a yes, and I will keep going through the materials until I hear something.
Yeah, please continue. I don't see any questions.
Perfect. Okay. So let's go through each of the modules in brief so you know exactly what you're getting inside this package. So there are 7 modules to date, and I know this is a very overwhelming slide, but I wanted you to have at least one summary slide where you can come back and say, okay, for each module, what is it going to cover? What are the technical skills the students will learn, and what does the lab do? And so these are the 7, and let's go through them one at a time now. So this is the first module, and I'll just actually, before I jump into the module, let me just give you the structure of the modules themselves, so that way it's a little bit easier, right? So when you click on one of those, you'll see this, and this is how you can kind of glean the structure. So the 2-week modules are like this. First, you'll have 4 50-minute lectures, so my slides are also there, right? And you'll notice the slides are written in HTML, which means that, right, I've been version controlling my slides, but it also means that if you want to add stuff or change it for your own course, you should be able to do that fairly easily. But the purpose of the lectures are to basically introduce those tech fundamentals, show domain data, as well as real software examples. And so one of the things that I have to do every year is go and make sure that all of the cool software that I'm showing still exists. Similarly, I do a lot of live code walkthroughs. So the big overhaul that happens every year is making sure that all the libraries that we're working still work, all of the demos that we've made still demo, and make sure that we really keep an eye out for which tricky technical parts we should be focusing on with every iteration. And so I do ask the students to bring their computers into the classroom so that way they can follow along, not just in lab, but in lecture as well, because we do a mix of lecture, discussion, and then sometimes we'll do some drawing and active learning type activities as well. During the lab, these are long hands-on design and development exercises, right? So we have two, right? In 1 week, we have one 2.5-hour time slot, but then we have two of these. So I basically have one lab over 2 weeks. It allows the students to work through it in a self-paced manner. So the students that are feeling really comfortable will run through it, get it done, get it out of the way. Those who are struggling can then actually spend more time learning the materials, getting additional support, and so on and so forth. And the way in which the labs are structured really allows for students to sort of do, here's your prep work before you even turn to the lab. Here's some in-depth programming materials in case you forgot exactly how this one myopic function works. Then I have them also do a lot of their setup and installation before they come to the lab. During the lab itself, then they're doing that self-paced work through. The TA will sometimes stop and explain the hard parts. So if you see enough students are struggling with exactly how this one function works, you might stop and then explain that piece there, very typical lab stuff. And then just floating around for guidance. So it's not everybody do this at the same time, but kind of everybody work at your own pace. And then the TA is really providing that glue within the room itself. And then after the lab, everyone submits their code via GitHub. So they get really, really good at GitHub, at least, and version control of their code by the end of the course. And so aside from the labs, the only other piece that I then have in the 2-week modules is a quiz. And these are basically 3 to 7 auto-graded, I call them gut check questions, because they're not trick questions. They're really just like, let's just make sure that you're keeping up, because then my submissions alternate, right? So 1 week, in the middle of the module, they submit their quiz. At the end of the module, they submit their lab, and so on and so forth. Okay. And I'll talk about the project because there is a project as well. I'll talk about that right at the end. So in the first module, we talk about web design. I have the students, we start with literally how does the internet work, submarine cables and all that. We talk about the fundamentals of software design. How do we listen to people and learn about requirements and start to translate those a little bit into technology. But really we focus on just doing a quick and dirty, like let's build a static website. I find this to be a really great way of just getting a better feel for who knows what, who's comfortable with what, and kind of, right, bringing everyone a little bit onto the same level with respect to version control with Git, being able to make sure that they're comfortable with HTML and CSS, and just sort of the fundamentals of how web applications work by focusing on design and development of a static profile website. So here's an example of my grad student, Megan. This was her submission from, I think it was 2022, right? And so this is what her final profile website looks like. It's very small, right? And so this is just a 2-week lab that they do, but this is something that they can then iterate over and actually turn into a real profile website if they want to. Then we switch tracks, right? So we switch from different languages, but I'm adding them one at a time. So then we go to data exploration. And in this particular case, I want students to get coding fundamentals, data science light, and really get a feel for exploratory data analysis, right? So this is not a data science course, but I do want them to be able to say, okay, I am comfortable with that stack of tools. I have Python, I use the data science libraries of Pandas, NumPy, and Matplotlib, and really just make sure that they're able to, acquire a data set, clean it up in some way, analyze it, and produce a set of graphs, right? And so here you can see in lecture 2.2, I actually do some live coding. And so I show them how to do that with a data set from the FAO. And so there's a lot of these beautiful public data sets that we can use and we do use in our class. And then they do the same thing, similar thing again in their lab, where they then produce a series of graphs to be able to interrogate, in this particular case, the relationship between corn prices and land use and other types of variables from some USDA data. So that's basically their submission, is a Jupyter notebook that has all of this integrated there. What I really like about this lab actually is that it also gives me insight into whether or not students are able to explain their working. Because they're writing a Jupyter notebook, it means they're not just giving me code, but they're actually explaining what each piece of code does as they move through the problem. From there, things start to get a little bit trickier. So we go into data management. They learn how to do data modeling, object-oriented programming. So previously, most students have only done Python as a functional programming. And so it means that being able to even do classes and think about how to break apart a domain into concrete objects and give each of those objects attributes and functions is a really core set of the work that has to be done here. And so we actually do a field trip to the agronomy research farm here at Purdue to hear about a real world problem. The farm manager from Acre, Rachel, has very graciously given us a sample data set. And so I actually have them kick around that data set and build a data model just in Python. And then they learn a little bit of SQL so they know how it fits into a database. But at the end of the day, we're working toward helping them basically build a web app in a framework called Django, which is a wrapper around Python. And so this helps them at least get that back end, okay, I understand how a data model works, that piece done. And so in this lab, they create a data model based on that agronomy farm management data. In module 4, they then actually build a full web app, right? So they do have to build a part of a web app in order to do this data model piece, but we're not really worrying about have they gotten all the other pieces working there. It's really in lab 4 where they develop an integrated farm management web application. And so here you can actually see, right, the data that we get from the farm, from the visit to Acre. Here's some an insight into that design the data model component, and then you can kind of see how much we actually walk them through. Here's how you build out each of the different components. And so they're able to take those web development fundamentals that they learn about in lecture and then apply them in their lab. In the lecture, I'm also doing a lot of here's how user requirements are gathered, here's how you translate them into technical specifications, here's some places where you might get tripped up as you're doing that. And so we're really focusing on making sure they understand how to actually then, right, spec out that framework and architect a web application using an integrated set of HTML and CSS for their front end, Python for their back end, and SQL a little bit of their data. And so you'll be happy to know everyone has submitted a working web application to date. So we do work very, very closely with them, but we do manage to get them to actually go from 0 to 100 fairly quickly. In module 5, we then talk about user interfaces and the value of actually engaging in usability testing and user experience design. So you can see here a sample from another one of my students, Stephen, who took this course early on. They were all very gracious guinea pigs and actually tried these things out. And so I'm ever so grateful for the students that took the course. But you can see Stephen's web application. It shows you how he did his paper prototype, how it then translated to the working web app that you can see on the bottom right here. And so in the lectures, we're really talking about, right, UX and UI fundamentals, right? What does it mean to design a user interface? What does a good user experience look like? We analyze and assess other software to be able to talk about whether or not we think they're usable and useful. And then functionally, they're learning how to use something called a Bootstrap framework, which is an HTML and CSS framework that you can use to prettify websites. And so it means, right, we're not asking them, please go hand code everything from scratch. No, they can now do that with ChatGPT, but it's how can you actually use these frameworks, these different kinds of ingredients to design a piece of software that is responsive to what you have heard, right, a real user or your user ask for. And so they upgrade their web application really with a focus on usability and user experience. Module 7 has changed a little bit. We now actually have 2 options. And so I have gratitude to Dr. Joe Dvorak from Kentucky, who had created the first module that is option 1. And so in option 1, you can basically use a Python library called Shapely to be able to create these different kinds of field geometries and then manipulate those field geometries to be able to lay out different kinds of data. So in this example, it's being able to even lay out which machines were moving where. And then in the second option, which I have gratitude to Thurawat Barrett, who is a graduate student in my lab and the TA for this course this year. He created a version of the geospatial data module that allows students to use Leaflet, which is a Python library, to actually embed a visualization of the fields at Acre, which you can see on the graph on the right, in their web applications. And so in both cases, right, so I would say, depending on what students are looking for and what their experience is, you might pick one or the other, right, from there. But in both cases, they talk about using, manipulating, and visualizing geospatial data. And then my Choose Your Adventure module feature of EdTech has varied from year to year. I had a guest module from another graduate student at Purdue, Anas Ahmed, who had built a computer vision module. So that is also in there. I did one on speculative design last year because there was a lot of interest in the more design aspects. I would be shocked if the request is not submitted for an LLM module this year. So we'll see. Usually I ask people to start telling me their thoughts early, so, because, you know, this is the last 2 weeks of the semester. The lab is not graded. It's just, you know, optional, experimental for fun. It's a good way for us to engage with new and emerging technology. So I get some interesting ideas every year. And that's everything. That's the entire course. And, you know, in 10 minutes, I'm about to do it for the rest of the semester. So I'll hopefully go a little bit more slowly, but if you're still hankering for more, you're welcome to go poke around and double click. But, you know, that's all of it. There was a project. I feel like we're running short on time, and so I'm not going to go into the project in much more detail. Suffice it to say, it allows for students to basically go from concept to proposal. So they don't implement this code. This is a writing project. And so I think about communication of technical specifications in this piece. I encourage the undergraduate students that are feeling entrepreneurial to think about this as a business pitch deck. I encourage the graduate students that are thinking about their topic proposal to think about this as a proposal to their own advisor of here's how I might want to approach this one chapter or this one part of my work. And so really it's a framework for students to be able to then think about different kinds of informatics solutions to problems in their domain that they're really focused on in the short term. But outside of that, you know, we have a lot of fun. We do a lot of drawing. Everyone makes fun of how much sketching is involved in my coding course, maybe as much sketching as there is programming. We go on a couple of field trips, and I've been really excited to try and grow the guest lecture component of this course back up. The first year I had one for every module, which proved to be a lot for me to manage. And so we toned it down, and now I just have the occasional guest lecture whenever I have somebody that talks about something that fits perfectly with the content that we're trying to cover, especially if you have real world use cases. But yeah, you know, I'm really hoping to try and see if there's broader interest in using and contributing to this course, and really thinking about if there's broader interest in an ag informatics learning community where we might even be able to share best practices and challenges we run into as we use this course. I'll just close out so that way we don't have to have a screen share for questions, but I want to thank our funders and incredible gratitude to my grant collaborators, many of whom are on this call, including our fearless leader, Dr. Saraswat. And, you know, of course, none of this is possible without all of our students who are patient and enthusiastic and curious. And I remain ever grateful for the opportunity to be a part of their learning. With that, I give you my thanks for your time and presence. I'll stop sharing. Thank you.
Thank you, Dr. Raturi, for a very engaging presentation. And let's give her a round of applause. You can use some of the icons for applause for doing this great service to all of us. And I do have a question on chat window that the use of GitHub is a great idea. But can you provide one or two examples as to how students have used these skills, or where these skills have led them to once they have been exposed to using GitHub?
Great question. Yeah. And I'll perhaps speak more about the graduate student experience, just because I hear more about what happens in their world next. A lot of graduate students actually will use GitHub and many of the tools that we've talked about in their work, whether it's to host their code, provide good documentation for both their advisor and their teammates. And so I've noticed that there is a continued use of GitHub in their research. You know, my students all take this course, and I'm grateful for that too. So they all definitely use GitHub. And then the other thing that I've noticed is that people will talk about, you know, even when they go into industry or when they go into other environments, they will at least being able to say that they understand version control and change management, one of those fundamental software engineering skills, demonstrates that they're actually, you know, thinking about the modernization of their toolbox. The other thing that I've noticed that, you know, it's maybe not as much on the GitHub front, but you asked in your question, it says, you know, places where they're using these specific skills. I would say the prototyping skills are the one that I've seen a lot more of. Many of the students, I've actually been fortunate to be on their committees after the fact. I'll notice we'll actually do some low-level prototyping, some mid-fidelity prototyping, use it as a tool for discussion with their committee to be able to say, this is what I'm thinking the web app might look like. In some cases, they might build it out. And in other cases, they might say, actually, no, I know how to scope a technology project well. And I know that, this is an entire body of work. Perhaps somebody else can do it after I'm done, or maybe that's something that they want to do after they're done. And so those would be the two things that I've really seen dramatically change. Is just, I'm hoping, people that are working more closely with the students after the fact feel the same way too, but, better documentation and coding practices, and then the ability to use prototyping as part of their way of engaging in digital ag research. I don't know if there are other pieces that you'd like me to touch on, but I'm happy to chat more if that's helpful.
Great, great. Uh, uh, Others in the webinar, please feel free to unmute yourself. And if you have any questions, please ask directly to Dr. Raturi, as we have few more minutes for this webinar. And there are several participants from India, and I'm quite happy to see that Punjab Agriculture University is specifically interested in launching something very similar to agricultural informatics, and I hope that they can benefit from this. So if anyone from PIU would like to say something or have any burning questions, this is your time. So there is another question. Has any conversation happened about offering this as an alternative to traditional senior design capstone course in ABE?
You're singing to me right now with that question. I would love that. I think for the last 3 years, I've just been really focused on refining this course. And now that I'm on this side, I kind of have been thinking a little bit about ways in which we could either integrate this maybe with the existing senior design capstone, or offer it as maybe another one. I would say that's TBD pending the next faculty retreat, but I would love for that to be something that happened where, if students weren't doing, let's say, machinery design, maybe they could take the software design track and follow along. But yeah, I'd love to explore that if anybody is actively doing that or interested in doing that.
Great.
I see a hand up also.
Yes, Vivek, please proceed.
Yeah, thanks, Ankita, for the very helpful session. It was great and very helpful for us. One, like, couple of things. So one is, can you please share the GitHub link of your repo, maybe in the chat? And second is, like, we are specifically looking at launching the course from AI perspective, AI and machine learning perspective. So was interested to know, like, which of these topics we can, like, basically utilize. I think data exploration and maybe the remote sensing one might be useful, but yeah, happy to or would be interested to know your perspective on that.
Yeah, that's definitely a very topical question right now. I think of this course as perhaps a precursor to somebody doing a deep dive into machine learning and AI. So there are components here that you might be able to integrate. So yes, indeed, module 2, which is on data exploration, would be a good, warm up for students. I think the data management module, if you wanted them to actually think a little bit more about data modeling, might also be productive. And then there are a couple of those future of ag tech ones in which, at least on our end, I want them to just get exposure to a particular technology, right? So that's how we had used the computer vision module 1 year. That's how we use the speculative design one. That's how we might do an LLM one this year. And so I would argue that really think of this course as just before your students go take that in-depth machine learning AI course, this is where they start. And thanks for sharing the link in the chat. I was trying to do things at once, so that was helpful. But hopefully that gives you a sense of how this course might fit into your maybe curriculum design process, Vivek. So just before is really what I would suggest.
Yeah, thanks.
Do you have students that you feel like already have the level of digital literacy that is needed to be able to take machine learning and AI courses, just out of curiosity?
We are launching for final year students. So by that time, they will have done courses on like basic programming and database. So yeah, I mean, basics should be clear by that time.
Okay. Yeah, the other thing I've been thinking about on that front, because I think the level of literacy is hopefully going to increase as we see more courses offered at lower levels before students come to something like this. And so when I think about this course, one of the things that I would like to grow a little bit more in it is actually that web development component, because I think one of the things that is missing is if I do build a machine learning model, how do I actually use that to drive a decision support tool? And so that's something where down the line, I'd really love to be able to build a module where they actually integrate, right, a machine learning model into the web application that's a lot more dynamic. I've been hesitant to start there because I wanted to just be able to get a feel for like, what are people comfortable with? And I still notice that we have students that have some discomfort with those early bits anyway. And so that's kind of why I have some of those harder things that point to machine learning as additive components, not necessarily required components of the course. But it'll be interesting to reflect back 5 years from now to see how much of that changes.
Yeah, thanks.
Great. Any other questions from anyone?
Other hand from JP Singh.
Yes.
Yeah, hello. It's a good morning to you, and it's very nicely you have explored all the courses offering for that. My query is that this course is for the undergraduate and the graduate students. So you designed the course number like 500 series, 500, 532, yeah, 500 series. Is it possible to the undergraduate courses to take the 500 series course?
Okay, I think I heard your question. There was a little bit of
Hello.
but
In our systems, in our universities, the undergraduate fourth year students, they are not entitled to register for the 500 series course.
Okay.
You can say poor in network. Am I audible?
I think
Ankita, am I audible?
I think I gleaned most of
Not.
your question. Hello. So I'll maybe.
Am I audible or not?
Yes, you are.
Am I audible?
Yes.
Yeah. Okay. Okay. Then please.
Cool. And please correct me if I've misunderstood your question, but what I'm hearing is
So you got my question?
Yes, I believe so.
My question is, in our university, the fourth year graduate students can register only for 400 series because your course is, I think, 500 series.
So Dr. Singh, we are having difficulty hearing you. So would you mind typing your question on the chat? Please type your question on the chat.
This undergraduate students, fourth year undergraduate students cannot register for the 500 series. So how the
Just for the sake of time, I'll maybe respond to what I heard.
Yeah.
There's two parts to that. I would say I had chosen a 500 number for my course just for Purdue. That doesn't mean that that has to be the number that you use for your course. This is the only way that I was using it to be able to signal to both senior undergrads and junior grad students that it's a good course for you. So the other way I would think about this is if it's actually 400 level courses that are more accessible to both your undergrads and grads, then you might need to work with your own department to decide what course level number it needs to be. But the materials, right? I think maybe this is the takeaway, is that the materials are really relevant for, right, senior undergraduate students who already have some skills under their belt, and junior graduate students who might be looking for that same set of skills. So whatever course number you need to be able to allow for that overlap, I would say try it out. Let me know how it goes. And then the other part of that I would say is, I've been thinking a lot about, as this course grows, do we need to actually split this into 2 offerings that maybe are run concurrently so that we're still able to get that mixed classroom benefit? Because I do feel like we get benefit from having both grads and undergrads in the classroom without having to have multiple courses. But that's more of a future iteration, but same takeaway applies. It's do whatever structurally works for your university. The materials still work for those 2 groups. And so that's why I tried to make sure that I had the audience slides and the deck, so you can kind of review that as you're deciding where you want to put the course. All right.
Any other question? Yes, there is a question or comment.
Okay, that's I got it. And because we are already
Yeah, Dr. JP saying you are not audible, so please type your question in the
we are
chat
already
window.
running the MTech graduate program. MTech in remote sensing.
So I see a question in the chat, so perhaps I'll just answer that one since it is written from Dr. Oweja.
Yes.
So it asks about the web application part covers remote sensing and GIS related applications. Will it be standalone? So that module is actually fairly standalone, I would argue. So option 1, where you use Shapely and Python, that's the version that Dr. Dvorak had built out, is something you can easily integrate into an existing GIS course, or you can run that as a thing on and of itself. The second option, which my student and I had built out, that was Leaflet integrated into a web app, I would also argue could be done separately, but you might have to do a little bit of pre-work to be able to make sure that they needed what they had what they needed to be able to set up the web application from scratch, right? And so I would say those are the sort of 2 different ways in which you can think about that specific module. We don't touch remote sensing data at all. Right, yes, there's satellite data that's used as a base layer in the map components, but think of it more as, at the current stage, it is really, can I visualize data on a map and actually integrate it into my web app, or can I create geometrical constructions that allow for me to manipulate the data, but it's not as tightly integrated as the other pieces. And that's an approach that I'm kind of hoping to lean into, which is have the modules be much more standalone, so that way you could take it and run with it. And so expect more refinements to try and allow for them to be slightly more, standalone in the future. I know that the folks at Tuskegee, Dr. Kwanzaa and team, had integrated several modules into an existing GIS course. And if I remember correctly, they had taken most of the Python ones. So it was, like number 2, which was on data exploration. Then they took data management, and then the GIS one. So it was something like that. It was maybe 3 or 4 that they plucked out for their GIS course. And then I think I see a last question in the chat, or maybe that'll be the last one, which is, what major courses are important for MTech and remote sensing and GIS students? I think that's a much bigger question than maybe we have time for. I would say there are lots of different skills that students need. I know, for instance, Dr. Saraswath has an entire GIS course that I would argue is critical for students of that type. I would say my course is really trying to help give them fundamental skills in being able to tinker with different types of technologies. And so if I think about what GIS students might be wanting, right, the data exploration module will be productive. Being able to understand what people want and translate that into technical specifications, I still argue is something that I hope everyone learns how to do, so that we were building things, even if they're data visualizations that are much more in service of what our stakeholders want. And then really thinking about data visualization, right? Story maps and Esri are an example of what happens when you have a beautiful data visualization and build an interactive web application to allow for someone to interface with your GIS data. I hope that this course gives students ideas of what's possible outside of maybe that one ecosystem also, right? So we've seen students, at least in their prototypes, talk about different kinds of mapping decision support tools that they might want to build out. And so we hear a lot more of the, I would say, creative applications of the course materials and the projects themselves. And so I'm sorry we didn't get to talk much more about that, because we've seen a wide diversity of student projects based on what they have learned in the course that they actually do then run with, whether it's in their dissertation or their master's thesis, or even sometimes as they're thinking about what class to take next to build out their learning pathway. But I think
all
I'll
right,
hand
so we are
you.
3 minutes beyond our slated 1 hour time slot. If anybody has got any burning question, this is your time before we close. Okay, so no more questions. So once again, Dr. Raturi, thank you very much for your time. And with this webinar, we have completed all the deliverables for the National Institute for Food and Agriculture project. And I'm very, very thankful to all the other team members who have very actively contributed to developing 3 full semester long courses and 1 2-week module for agricultural informatics. I have also shared the URL for the course webpage, where anyone can go and just fill out a small Google form to get access to the 3 full semester long courses and 2-week module. And most of these courses are modular in nature. That means you are free to choose whatever module you would like to incorporate in your existing courses, or any new program that you want to launch at your university. Just be aware that we would like to be provided an acknowledgement if you are using any material. And apart from that, everything is available to you for free, as we believe in sharing material using the open source communities practices. So yes, so Dr. Raturi has once again shared that link. Thank you very much. And thank you all for participating. And I would also like to thank several participants from India, where the time is really quite late, 10:35 p.m. So thank you for spending your time on a special day where the birth of Lord Shri Krishna is being celebrated in India today. So those of you who are celebrating Janmashtami, happy Janmashtami to you. And once again, thank you very much for coming to this webinar. And as I indicated in the chat box, the YouTube link will be uploaded on the course webpage. So if you have bookmarked that webpage, you can access it from there. Otherwise, you are welcome to drop me an email, and that way I will be able to send you that link directly. So thank you. Thank you all.
Thank you, Saraswat. I, behalf of my PU team, I thanks to all of you. Thanks especially Ankita for presenting the very nice course schedule that will be beneficial for us. So thank you, Saraswat, Dr. Saraswat. Thank you very much.
Thank you.
Awesome.
Thank you. Thanks a lot. Bye-bye.
Everyone, take care. Bye.
Bye.